This is Chapter 3, Physics 102A, Homework Solutions at Porterville College. Starting with number 17, we have a position vector. Here I have it in the stacked vector notation, negative 2.3 and negative 4.0. To find the angle it makes, we find the arctan of y over x. That gives us 60 degrees. The picture helps to show us that it's in the third quadrant. And remember, 60 degrees goes off like this. And so if that's the case, remember to make that third quadrant adjustment just to add 180 degrees. So 60 plus 80 is 240 degrees. For number 19, we have the velocity vector given. What is the speed? Remember that speed is the magnitude of velocity vector. This is just Pythagorean theorem here. Square root of x squared plus y squared. And we get 22.8 meters per second. (21) Maximum range. This is a good setup for the range equation. You can use range equation, remember, because it's on level ground. It's looking at the point down range where it comes down to the same altitude where it was launched. Maximum range is 45 degrees, so sine of 2 times 40 gives sine of 90, so the sine function goes away, and we're just left with maximum range is v0 squared divided by g. We plug in those numbers and get 66.4 meters. Number 27 is a basic trigonometric problem. A 3, 4, 5 triangle. What are the angles on the sides? Let's pretend we don't know that that's a right triangle. That angle, I labeled them angles alpha, beta, and gamma. Let's pretend we don't know that gamma is a 90-degree angle. We can use law of cosines to find the first angle. So in this case, I made law of cosines to find the angle gamma. Just plug in those numbers, and we get down here on this line that cosine of gamma equals 0. That makes gamma a 90-degree angle. From there, knowing that we're dealing with a right triangle, then we can use our trig functions. So to find angle alpha, cosine of alpha is 3 over 5. So alpha is the arc cosine of 3/5, or 53.1 degrees. Then angle beta, cosine of beta is 4 over 5. So beta is the arc cosine of 4/5, or 36.9 degrees. Number 33, we have a angle. This is a right triangle here with an angle of 6 degrees. If you're driving along the road 5.5 kilometers, that means that that's the hypotenuse, because that's the street right there. So the hypotenuse of our triangle is 5.5 kilometers. And we want to know what is y, the elevation drop. So some simple trigonometry. Sine of 6 degrees is y over 5.5 kilometers. So we get y is 0.575 kilometers, or I converted that to meters, 575 meters. Number 37, more trigonometry and vector math. It gives the two position vectors. Find the magnitude and direction of the vectors. So magnitude is x squared plus y squared, the square root of that. Again, Pythagorean theorem. You find the direction by taking the arctan, remembering to make that quadrant adjustment if you need to add 180 degrees. So for position vector 1, we get a magnitude of 5.61 meters. We get a direction of 295 degrees. Notice I had drawn the picture ahead of time, so I can see 295. Yeah, that works for fourth quadrant. For position vector 2, Magnitude, again, Pythagorean theorem, and I get 3.69 meters. Theta is the arctan of y over x, so 0.98 over negative 3.56. That gives me negative 15.4 degrees. I look at my picture and I see R2 is going off in the second quadrant, negative 15.4 is off in the fourth quadrant, and then I realize, okay, the calculator gave me a fourth quadrant answer. I need to adjust by adding 180 degrees. So I get 165 degrees. Number 41, in the black I've written, I've done it less precisely in the black, and then in the blue I came back and gave a more precise answer. But number 41 asks about what angle these make from each other. So here's R1, there's R2. We want to know the angle they make from each other. The book said, hint, see what angle they make off the x-axis, so that's what I followed. R1 makes a 65-degree angle off the x-axis. R2 is 165. You can add them together and get 230 degrees. Now, generally, when you have two vectors and you want to know what angle they make from each other, the answer to that shouldn't be more than 180. 230 is the long way around, but there's a shorter way between them, so let's go for that. It's just 360 minus that 230, and that gives the blue arc that I'm pointing to right now. 130 degrees. Now, with a bit more precision in these numbers, we would have gotten 130.6 degrees. So here, instead of saying 65, I was more precise, 64.76. Here, instead of saying 165, I said 164.6. So if you follow the same method with those more precise answers, you should get 130.6 degrees. Number 43 involves these three vectors, A, B, and C. Here it gives the magnitude and the angle, and we need to break these down into their x and y components. So here I've drawn a picture. Remember, the x component of any angle is its magnitude times the cosine. I'm sorry, the x component of any vector is its magnitude times the cosine of its angle. The y component of any vector is its magnitude times the sine of its angle. So the x component of A is A cosine alpha. We have 6.4 meters times cosine of 80 degrees, and there we have 1.1 meters. The y component of A is A sine alpha, so 6.4 times sine of 80, 6.3 meters. And you follow the same procedure for the rest of them. You'll notice that for vector C, its x component is 0 because it goes straight down the y-axis. Number 51. Number 51 says a snail crawling on a sheet of paper. It gives it starts at the origin and it makes it to 5.6 and 4.3 centimeters, and it does it in 1 minute. So let's figure out its average velocity vector. Average velocity is change in position over time. So here's its final position minus its original position. 5.6 and 4.3 minus 0 and 0. Divide by 60 seconds. And so here we have the vector 5.6 and 4.3. Those are the x and y components. Divide by 60 seconds. So when I divide those by 60 seconds, here's the answer in I hat, j hat just lost my train of thought. Here's it written in terms of I hat and j hat. So 0.0933 I hat plus 0.07167 j hat. Keep in mind the units, I've kept in centimeters per second. If we want to know the magnitude of velocity, just use Pythagorean theorem. So you should get 0.1177 centimeters per second. Number 55. This velocity vector is going 950 meters per second at an angle of 75 degrees, and it's at a time 55 seconds into the flight. So first let's find the x and y components of that vector. V sub x is v cosine theta. V sub y is v sine theta. So you just do the v times the cosine or sine of that angle, and this gives the x and y components. For the average acceleration vector, change in velocity over change in time, well, we have the velocity components minus the original velocity was 0, 0, and then you divide by 55 seconds. So you're going to fill in for Vx and Vy. This is what we got in Part A, 245.9 and 917.6. Divide by 55 seconds, and you get your answer right here. Number 57 involves a baseball. What you have to keep in mind here is that it's going in the opposite direction. So let's call the original direction of travel the positive direction. V0 is positive 32 meters per second. Final V is negative 36 meters per second. So when we do change in velocity vector, final minus initial, it's going to be the final negative 36 minus the initial 32. So we get a change in velocity of negative 68 meters per second. Or we can just say the absolute value of that, it had a change in speed of 68 meters per second. Here I'm just using the absolute value of that. For Part B, the average acceleration vector, change in velocity over change in time. Well, in Part A, we already got change in velocity, and I'm just using the absolute value of that, 68 meters per second, divide by the time, 0.75 times 10 to the negative 3 seconds. So we get 9.1 times 10 to the 4th meters per second squared. Since it's asking about a vector, it's appropriate to say what direction. So just to remind that the direction is opposite the original trajectory. If I had not kept the absolute value, if I'd left it at negative, this would actually be negative 68 meters per second, and then we get acceleration is negative 9.1 times 10 to the 4th meters per second squared. But still, we have to identify when we're answering the question, what does this negative mean? Well, it means opposite the original direction of travel. On Part 2, we will start with number 63.